Welcome to SharkNet General Interest Seminar. My name is Isaac Ye. I'm an HPTC based out of York University. Today's seminar basically targeted for the beginners who never or rarely used our system for running their AI or deep learning code. So in this seminar, I'll probably do a lot of demonstration using the terminal, and I'll go like a slide side by side with the terminal and then showing you where we are doing, what we are doing. So basically what we want to cover today is I want to demonstrate how to set up and run Python code using GPU on Graham. And I'll introduce how to write a job submission script for PyTorch frame. And I'll introduce several different approaches in using multiple GPUs plus multiple nodes. And at the end, I'll show you how to use TensorFlow for PyTorch. If you're interested in following my demonstration, I already put my file in the temp directory in the Graham. If you go GIS 2021 November tar gz, you can access this file, and you can copy this one to your directory, and you can follow me one by one. So basically what I'm gonna do, I am going to present how to set up and how to submit your job for many different configurations. I cannot show you all the different types of configurations, but I'll show you very much like a bare bone structure to use multiple GPU and multiple node together. And furthermore, the framework we're going to use is PyTorch. So unfortunately, I'm not going to touch about the TensorFlow today. So please be aware. Let's get started. First one is deep neural network. Once again, today's seminar is not about delivering the knowledge about the deep neural network or what is the AI, what's the backpropagation, what's the multiple point of or multiple different types of neural networks, something like that. However, what we know is here, we know these days everybody wants to use deep neural network to solve their research. So even simulation, analytic problems, visualization problems, many different fields actually trying to use this new technology, relatively new technology to their research. So I'm sure even in this seminar, there are a lot of people actually want to know how can I use this one for my research? And then the first step you probably wonder is how can I run very simple code? You probably downloaded from the tutorial or somewhere. How can I run this kind of deep neural network on Graham or one of our Compute Canada systems? Because not many people actually have GPU cards in your laptop or in your Linux box or something. So here, what I want to present is Compute Canada has awesome resources. You can always rely on, use it for your production. I'll briefly mention about the Google Colab for the development in the middle of the seminar, but basically here what I want to say, emphasize is Compute Canada resource, especially Graham I used for this seminar, is really good option for your research. You can always rely on, you can use on. Okay, so today's target problem is classification problem. MNIST is one of the popular classification problems for AI or deep learning, something like that. Basically, kindergarten kids actually wrote down their handwritings for the numbers from 0 to 9, and you feed this data, over 60,000 data set. You train your model using this handset image, and you try to make your algorithm to reply back to you with the exact number prediction. So when you feed this image of 4, hopefully your algorithm reply back with the answer, the number is 4, something like that. So we will try to run this code on our Graham server. I know you guys can find a lot of good demo and a lot of good, let's say, tutorials which use Google Colab or other like clusters for this problem, but you may wonder sometimes, how can I run this code on Graham? Graham is very expensive, large, massively parallel computer. How can I use this resource to solve this kind of simple MNIST problem? So this is our target problem today. There are many different levels of different level of parallelism, model parallelism, data parallelism. There are many different things, but I'm sure MNIST in this case, we use data parallelism, which means basically you chop the data and send the chunk of data to each node, and they work on each own data set and reply back to the result. So there is a model parallelism, definitely, but I believe the MNIST code I wrote or I modified actually is using data parallelism here. There are many different types of, we say, deep learning framework, many different options for you to use for like a deep learning or AI. The most popular two is, I believe, PyTorch or TensorFlow. Each one has its own benefits, pros and cons. PyTorch we're going to use today, and it's rapidly growing in community, which is supported by Facebook. Maybe I need to say Mate. They changed the name, right? Anyway, and it's also very close to the Python. So PyTorch is much easier than TensorFlow, at least for me to learn, because I know Python, so PyTorch is a very natural extension. But TensorFlow, to me, it looks like a little bit more like a CUDA programming. So you have to be more specific to handle a lot of things in TensorFlow. TensorFlow is supported by Google, therefore they have really big market. And also, as far as I know, TensorFlow has a benefit over the platform. So TensorFlow can run on the mobile, PC, laptop, whatever heterogeneous platform. But the PyTorch has a limitation. So PyTorch is popular for the research community because this is cheap and easy to learn. For a lot of grad students actually love to use this one to accelerate their program or adapt, deep neural network to their program. Yeah, as I mentioned it on the left side, it's easy to express. TensorFlow is a little bit difficult, but as far as I know, TensorFlow is well documented. So if you're good at programming C++ or CUDA or something, I believe TensorFlow is much easier than PyTorch as well. And also, we do have 1.1, which is latest, I believe, for PyTorch we have in our system. And TensorFlow, we have 2.4 version. But today, once again, we will use PyTorch only. GPU resources available in Compute Canada. As you see, Graham, Cedar, Beluga, Negra has no GPU, by the way. Narval, which is the latest adoption to our computing infrastructure. Narval has more nodes, but I'm talking about the GPU nodes only here. Graham has a lot of GPU nodes, depending on what type of GPU types you want to have. We do have P100, V100, T4 Turing. Today's seminar, we're going to use T4 only. This is the type of the GPU card. Each GPU card has their own specification. I will show you a little bit after this one. And it has its own like a note when you submit your job. I'm going to show you how to use this one later too. Cedar has only P100 Pascal, Pascal 100 or P100. Beluga has a Volta. Volta is faster than the P100 usually. And Narval has one of the latest kind of GPU card, A100, but unfortunately we have only 40 gig one, not 80 gig one. But this is unfortunately in testing. I was trying to use this one to make us some result, all the things for this seminar, but unfortunately the timing wasn't good for us because they are still changing a lot of things. So I couldn't use Narval for today's seminar, but maybe next time I can definitely use Narval and show you how to use that as well. Which GPUs you're going to choose? If you really need to use Tensor Core for your tensor calculation, you you definitely need to use V100 or T4, definitely 800 too. I didn't put the 800 here because it's not in our production mode. As you see, it has its own like a, specification. So double precision, if you're looking for, you can use T4 because T4 only works for the single precision. But most of, let's say, visualization problem or classification problems are fine with the T4 because it doesn't require double precision. So we're going to use T4 Turing. And here is some benchmarking results you can refer to. But once again, it depends on what kind of jobs you want to run on. So it's totally up to you. But these are all available in Graham system. But different nodes, different physical nodes, have different GPU cards. So you have to know that. So if I were you, see that Graham has a very limited number of node for the V100, right? So if you need to run a lot of GPU core using the V100 on Graham, that's not a good idea. If you really need to use V100 for your job and you plan to run like a lot of like a GPU cores, you better go to the Beluga and run it. But if you think your job is middle core and you don't need to have a double precision, I'm sure T4 is good target for you. So you can come to the Graham system and run on it because that means your queuing time will be much, much less than other situation. So let's think about how to set up the PyTorch and all the things. Maybe this one is too easy for someone who already know how to set up the virtual environment and set up the, Python packages, all the things. But, just for beginners who never learned or never did this one before, it could be good information for the beginners. Anyway, once again, I'm in the Graham. As you see, it's my ID. This is Graham login node, and this is a directory. If you never use the Linux system or Unix system, might be a little bit different from what you've been to, like a Windows system or Mac Windows only. But this is command line terminal. So I am going to use the command line terminal. Here I am. First thing you have to do is you have to make sure what kind of modules you have. So to do so, I will just show you from the beginning, like connecting. So let me clear, because it's better to show you from the top. So if you type the module list, it will show you what kind of modules you have. If you don't know what's the modules, you probably missed our new user seminar. Module is pretty much like a pre-stacked kind of software environment for you. So you already have this one whenever you log in. So you see there's intercompilers and all the things, blah, blah, blah. But this is not about the new user seminar, so I'm skip that. All you need to load is module Python. If you can, open your terminal and follow me. If you never did this one, it's a good lesson for you to set up all the things at once. And then, oh, sorry, I forget load. And if you type module list, you see that I added Python here automatically. We do have very different versions of the Python, but when you just type the Python itself, it will upload automatically the default version of the Python, which is 3.8.10 here. We need some NumPy, those kind of things later. So I'm going to SciPy stack. SciPy stack has a lot of packages inside, as you see here. Okay, here. SciPy stack has, as you see, we need the NumPy, we need the SciPy, we need the pandas, we need like a graphing tool libraries, all the things we need, right? So we need that. Okay. If you're looking for sklearn will be added as like a virtual environment. It's gonna be installed using the PIP later. Okay, for now. Okay, so if I type module list, again, I do have a Python and I do have a SciPy stack. These two are key modules for you. And then what I'm gonna do is virtual environment. This is the command to generate your virtual environment. If you're not quite used to what the virtual environment is kind of another shell, another like a layer, so that you make your own layer on top of our resources. So whenever you're getting into the virtual environment, that's yours. So you're gonna control everything within this virtual environment. You know, the word itself explains, right? It's a virtual environment for yourself. So you can name it whatever you want. But in this case, you can do like a Isaac's word, whatever. You can do whatever names you want. So I already use the PT and PT2, but I'll name it like a whatever here, right? However, I want to say one thing here is, if you type ls-a, it will show you all the hidden directories inside. And then especially here is cache, you see that, right? So if I clear and go to cache, and then if you type same thing, you see there is a PIP, right? So whenever you have this kind of old history, that sometimes deroutes you to the wrong version of the wheels. I'm going to explain later a little bit more. So what you have to do for now, just follow me. Just erase the cache if you need to follow me. Be careful to erase anything. Unix system is almost impossible to recover any deleted files. Okay, so if you type A, I don't see any cache anymore, right? Good. Because I noticed that if you leave your cache file and if you did this kind of virtual environment before, it will pick up old version of the PyTorch. That's why. We're gonna use the latest PyTorch. That's why I erased that. Anyway, so same thing, virtual environment, no download. And the name, PT, let me say 3. I already have a PT and PT2. That's why I use PT3, but it's up to you. In our wiki page, we use the EMB. It's totally up to you, PT3. Then it will automatically generate the virtual environment. Then how can I get into the virtual environment? If you type PT3 as ls is listing, you see there is a bin and lib and everything. So one more time. So there's binary activate. This is the one you have to use. And if you do deactivate, oh, within the activation, sorry. So you just need to do is source PT3 bin activate. Then as you see, there is some indication you are in the different world. What does no download flag means? In this case, we have some stacked, how can I say that? Some environment to generate some packages. So if you don't use no download, you'll probably generate some like a virtual environment, but it's gonna try to get some necessary component outside of our system, which not working well with us. That's why by putting into the no download, it will force to use our resources. So I activated I'm in the virtual environment. Okay, and then what I'm gonna do for now, I'm going to update. It's kind of good habit if you do upgrade PIP. PIP is package installation maintaining program, or like a command, I'll say. So you better update PIP first. Then if they need some newer version, they'll download it and install it. Because if your PIP is old version, they couldn't find some packages well. Okay, I'm updated. So let's try to get out first, deactivate. And you see that there is like a different word indication disappear. So you now came back to your shell. So once again, let me do that. Activate it. Okay. This time, we want to check the wheels. Wheels, I don't want to explain too much about wheels. You can think about wheels as like a module or pre-packaged, something like that for our system. So if you type avail wheels, it will show tons of packages there. So we're looking for, at this stage, like a sklearn, for example. So avail wheels, you type just sklearn. I'm not going to use sklearn today, but many people need like a sklearn later. So I'm showing you this one here. So as you see, there's a wheel names sklearn is available, and it's Compute Canada, PyTorch, sorry, Python version 2 and 3. It's a general architecture, what kind of architecture it is. So pip install. If your wheel is available in your local system, you have to use no index, which means pip is not going to look for sklearn from outside and install it. So if you do pip list and grab sklearn, you see that it's pip list is the show all the packages within my world, basically in Python. So you see that it's installed. Okay, now I'm going to install PyTorch. So to save some time, let me copy and paste it. So if I briefly explain it, same no index because we're gonna use the wheels. Oh, before that, we need to check the wheels, sorry. Avail wheels torch. We don't have a name of PyTorch, we have torch. You see that, we have 1.10.0, right? Or you can do torch, any torch related things. You can see that, right? So we need, like, basically, I briefly showed you torch vision later, tensor board, and I'm sorry, some visualization, and torch text and torch audio. It's good to install everything together. So what I'm gonna do this way, pip install no index torch, torch vision, torch text, torch audio, and click it. Okay, I'm done. So you're done probably, clear. So once again, pip list, you can do grab torch. You can always check your package is installed well or not. Yeah, we do have pretty well. So we are ready. Our virtual environment is done. Okay, I'm gonna deactivate. If you're getting in again, let's say source PT3 being activate. And if you do the same thing, pip list grab torch, I'm sure it will give you the same thing. So it's saved, it's there. Let me deactivate quickly. So we are done with the setting up. Okay, once again, this is our target. We do have 784, like we say, input node, and we do have 10 output node, right? And then we do have multiple layers. If you never learned this kind of things, we do have a video in our YouTube channel, which I did it for the summer school. Yeah, I explained about this deep neural network. You can check it out. Basically, this diagram shows you much likely MLP, multi-layer perceptron. Anyway, this is basically the code. I'll show you here as well. So this is the file I already gave you. I don't use Nano much, but I will show you how to use Nano. So Nano is pretty much like a text editor you can use from whatever operating system offers. But unfortunately, I'm not quite used to use Nano. I am probably old person about this one. Anyway, I'm using VI much. So as you see, this code actually written in terms of torch. Okay, so we do have like a data download, all the things. There is a little issue with the data download. That's why I provide you with the data already there. So you don't need to worry about that. Okay, so basically we have linear model and multi-layer model, and then we have some add-on to check out what kind of GPU things, all the things. So this is pretty much like the code. Okay, so how do I run this one? Well, it's easy. we can probably run this one interactively first. So let's use a celllog command. Celllog is you asking us to allocate certain chunk of the resources for your interactive mode kind of running. So celllog time, I'm gonna ask only, let's say here 10 minutes. Number of tasks is 1, because it's a single CPU job. I mean, single GPU job, sorry, per task. This is typical to say 3 or 4, or many times some people use 6. This is typical practice. When you ask to use 1 GPU, you assign 3 CPU to handle some data communication, all the things. Because GPU is much faster in calculation-wise, much faster than CPUs. Therefore, it's good to assign 3 to 4 times more CPUs than GPUs, which means if you're gonna like ask 2 GPU, you may assign like a total 6 or 7 CPUs. But we do have a command per task. So per task means how many workers you're gonna generate, basically. So in this case, we're gonna use single GPU worker. So we assign 3. Okay, and memory-wise, it's totally up to you, but I believe 8 gig is enough. But you can give more because we have, this is the one you have to indicate what kind of GPU card you're gonna use. I'm gonna use T4. For now, I'm gonna use 2 GPUs, for example. So once again, this option, GRES, okay, is indication about the GPU. So what I told you in the slide previously here, Pascal, if you want to use a Pascal, you indicate nothing. Okay. If you want to use a Volta, you have to indicate, I want to use a V100. Okay. So as soon as you indicate V100, you have very much like a low chance to run your job right away. Why? On Graham, we have only 7 nodes of the Volta. So as I mentioned, if you want to run your Volta, you better go to Beluga, because Beluga has lots of nodes with the Volta. I'm using Turing T4, so that's why I'm showing this way. So this is the one you have to indicate. And account, billing account, Isaac. Tasks, CPUs, not CPU. This kind of things always annoys me. Is sometimes n tasks or something like that. While I'm waiting here, I'll show you my different thing I want to show you is, this is Google Colab. I'm not sure how many people knows about the Google Colab. Google actually provides you awesome environment to develop any code. Let me type Google Colab. So it's a free. You can always run your code whenever you want. And let's say you can start with this one. I already did it here. So this is my MNIST, same code. I run it on the Google Colab. So downloading the data set and running some checking, all the things I did it here. What I want to say is here you can indicate you're going to use the GPU. You have to indicate your hardware accelerator. But unfortunately, they only allows you 1 GPU for your account, like every time. So you cannot run multiple GPUs as a free version. If you want to use multiple GPUs on Google Colab, you have to pay the money. So one thing you have to know is we were in the login node, but now we are in the certain node. This is computing node. It's a different one. So if you do the module list, you see that we do have the same modules, actually like a pass to here. That's a good one. And also we are in the same directory. That's a good one. So all you need to do is activate your virtual environment. So source PT3, deactivate. Okay. And then there's a code I want to run. Okay, so simple, MNIST Py. It takes a little bit of time because it's generating some, what is it, figures. So sometimes matplotlib library takes a long time to make it buffer. So you see that there's a GPU is running, right? 2 GPUs running. The type of the GPU is Tesla T4. And we do have hyperparameters, 159,000 parameters, hyperparameters. They're going to train it. I think I gave only 5 times of epoch, so it's going to be done pretty soon. Once it's done, I'll move on. But basically, you will see this kind of result. You see that my training loss, validation loss, test accuracy is actually, changing, right? Because MNIST is, once again, is 60 down. Oh, it's done, right? So if you go, sorry. This is the Slurm like output. Slurm is our scheduler name. Oops. Oops. It works pretty well, as you see. Okay. Okay. Once again, we are not in the login node. I'm in the the node for the computing resources. If you're done with your job, it's better to get out of there. So exit. Then we are kind of escaping from our resource allocation. So you see that the node name actually changed to the login node. I'm back to the login node. Okay. I'm going to do only one of the job here is basically, what if I want to run this one interact now using the scheduler instead of interactively? Interactively means you can see what your resource is and you do whatever you want. So interactive mode is good for your development when you need to run your code for a short time to check your writing is fine or your syntax is right, all the things, and your code is working or something like that. But if you need to run longer time of submission, you definitely need to use our scheduler. So for example, I have multiple things. So for your information, job 1 GPU, 1 node, okay, multiple GPU, 1 node, multiple GPU, multiple node for different types of configuration. For now, I want to show you job 1 GPU 1. So see that I assigned a single GPU, but at the same time, I assigned the 3 CPUs and everything else is the same. But when you write down your script, you have to make sure you're starting from your just your login node or login shell, we say. So you have to indicate you have to tell what kind of modules you need to stack on. So I need to load Python. I need to load this SciPy stack. I did it right at the beginning, right? And then you have to make your computer or a computing node to source or start your virtual environment, right? This is starting your virtual environment. And you move your a working directory to the target directory, and then you run it. I prefer to use absolute path here instead of relative path because sometimes there's some misunderstanding going on. So I better keep this one as absolute. It's much efficient in my sense. That's why I'm using absolute path. But anyway, you need to move to the target directory and you just command what I did. Okay. For multiple GPU thing is same thing. For the single node. Oops. Oh, I didn't write down. Sorry. VI job multiple GPU 1 node, right? So you see that I indicate how many processes I'm going to generate or workers here. So I indicate I want to use 2 separate jobs, but it's in the single node. This is indication what kind of GPU you're going to use and how many GPUs you want to use, and everything is pretty the same. So as you see, we assign 3 CPUs per task, but I ask 2 tasks, right? So when I ask, or when I submit this job to the scheduler, scheduler will try to hold 6 CPUs for this job, okay? And then everything else is the same. But one thing I need to say at the end is I use the srun command here because this is basically parallel computation. So let me try to submit this one. sbatch job m GPU 1 node sh job submitted. We call this as job ID. And if you do, you better use your user ID, okay? Or me is Isaac. So if you type it, let me make it a little bit bigger to show you better vision. You can see that. I ask 1 node, single node, 6 CPUs. Why? I ask us 3 CPUs per 1 GPU, right? So here is some GPU information, minimum memories, and how much time, something like that, right? Once again, you guys we will have a lot of people, so let me cancel. And I'll use a CC account. It's running right away. Yeah, it's working. Okay. While I'm waiting for, let me move on. Okay, I know how to use like a single GPU or multiple GPUs in a single node is fine. I'm okay with that. How can I use multiple GPUs? My code is really big. I want to use multiple node, multiple GPUs. Let's say I want to use like 100 GPUs together. Well, we don't have any single machine with 100 GPUs, which means you have to use multiple physical nodes there, right? So in our configuration, there are basically 3 different types of configuration. One is DDP, which is distributed data parallel. Another one is PyTorch Lightning. This is typo, Lightning. And the last one is Horrible. There are 3 different ways. I tested all 3 different ways. It works pretty well. I haven't got a chance to benchmark it, but it's working pretty well. So I'll explain you one by one quickly, because everything else is pretty same, and how to submit the job is the only matter. So as you see here, here's a DDP case of MNIST. So if you quickly check, you see the distribution model actually used, right? Okay. So I already make a script there. The script name is this one, job multiple GPU, multiple node for DDP. So everything else is similar, but we ask 2 nodes, not just 1 node. And we ask 2 GPU, okay? And then we ask 2 processors, which means each node will have 2 processes, which means you're gonna have 4 total 4 processes working together, okay? Therefore, each task will have 3 CPUs. So it actually indicates we're gonna have 12 CPUs you need, right? Everything else is similar, activating. And this one you have to indicate. This is important part. You can find all the information in our wiki page, okay? But wiki page has a lot of things. That's why I squeeze it to here. So you can look at my video or slide later, or you can refer to our wiki page for further like a deep explanation. And also at the end here, it's a kind of parallel job. So you have to use srun and code. And they're using some TCP communication behind the systems, like an MPI. So it's very similar to the MPI, right? Word the size. If you go in, you can see the rank, all the things. It's pretty much like MPI. And if you submit it, let's say, before that, let me check if our job is done. Yeah, it's done. Here, this is the result from multi-GPU thing. See that we used a 2 GPU system and it worked pretty well. Because this is our new feature. You guys need to use this one. MII. It's a kind of new feature to help you to find the command easily. Yeah. On Graham, I'm not sure other servers, but Graham we have. So DDP is the same thing. PyTorch Lightning is another way to do the multiple GPU on the multiple node. Let me just explain what's the difference. So you have to use some CUDA library, and you're gonna use MNIST. It's the same thing, nothing different. Okay, but your code must be written using those kind of library. So when you do, here is a separate code. Oops. So you see that PyTorch Lightning as another library module, right? So we can use that. So let me go to the Horovod quickly, because Horovod we need to install something. A Horovod is another popular like communicating tools. So we have, as I pointed out, we have to install it. So let me start my virtual environment. Oh, before that, I need to upload NWCL, I guess. So you have to module, load, CUDA and CUDA library, neural network. And you have to module, load NCCL. This is another type of communicating library, like a TCP, something like that. And you check it out, source, avail wheels, Horovod. We do have a Horovod here. So same process, pip, what was that? Install no index, Horovod. Yeah, I already, once again, I'm sure if you do LSTMP, it's a Graham server, by the way, GIS, you can find the whole MNIST code and script actually tarred and zipped here. So you can find it. So I do have a Horovod, but Horovod requires a little bit more setup. So cat bash rc, you need this kind of environment. So I actually put it in here. You can see the environment. If you download my PDF later, you can see what you need to set up. Okay. You just need to remember there's a further setup you need to do on your login script. So Horovod, okay. As you see, we use the Horovod modules to run the code, and mGPU mn Horovod recover. Yes. So as you see, we need to have NCCL. I already put it here, and everything else is same. Only difference is what kind of modules you need to load, and then how can you run it, except the DDP. DDP, you need to indicate what's the kind of hosting name, all the things. I already did it. So let me show you quickly. This is the result of the DDP. And you can check it out later by yourself. Lightning works pretty well, but you see that, you know, kind of screen out is a little bit different, right? You see that how many members actually joined and then how many things actually working together, and just binary type of writing. So it's a little bit different. And finally, yep. Nope. I can't see it quickly. Yeah, horrible days here. Yeah, horrible works pretty well. So see that we have total 4 GPUs actually working on.